So I was woken up in the night by a thud on the hull of our boat. And when I came up on deck, I found that we were surrounded by pieces of plastic. Now, at the time, I was 1,000 miles from nearest land. In fact, the closest people to me were in the space station in orbit above my head. And yet, there was this evidence of human life and waste in the most remote part of our planet. Now, at the time, I was actually hitchhiking on board this crazy-looking boat called Earthrace as a way to get to a new job as an architect in Australia. I wanted to get there without taking an aeroplane, so got a job on board this boat, where I then came across handfuls of plastic on our daily swims in the middle of the ocean. We would then stop at these small islands and we'd find that they too were covered in plastic instead of sand. We found that the locals were struggling to catch fish because the commercial fisheries had emptied their waters. They were struggling to grow food in the ground because the rising sea levels had caused their soil to become so salty that their crops wouldn't grow. But the knock-on effect of this was a new reliance on importing packaged food and drink that all came wrapped up in this new, strange material, plastic. And with nowhere for that plastic to go, a lot of it ended up getting dumped on the beach, thrown in the ocean, or burnt. And it was that really toxic smell that kept getting at my nose in all of these islands. And when I found out what that chemical was that I was breathing in, dioxins that are released through incomplete combustion, I realized that there are chemicals that we really do not want inside our bodies. So much of this waste, it's either getting burnt or it's making its way downstream to the ocean. And we now know that about 80% of the plastic that we find out there at sea is coming from streams, drains, and rivers like this. And ultimately, everything runs downhill to the ocean. When it meets the ocean, it then reaches these ocean currents, our planet's spinning, creating this Coriolis effect. And in our northern hemispheres, we have two big clockwise rotations of current, and in the southern hemisphere, the same thing, anti-clockwise. But in the center, in those red patches, it's really calm, the center of the high. And that's what, as scientists, we call a gyre. And it's the accumulation zone where all this plastic, 8 million tons of it a year, is eventually ending up. So back in 2010, after this hypothetical computer model was first published, I set out to find out what was really there, searching for these islands of plastic that maybe we could clean up and bring back to land. But when I got there, I realized that actually these islands didn't exist, but that these huge areas of our ocean were instead covered in these fragments that we call microplastics. They're smaller than your little fingernail, and the majority of the plastic in our ocean is actually this fine soup that's the same size as the plankton and makes it almost impossible to clean up. We then started catching fish and found that they were actually mistaking this plastic for food. Now, this opened a whole new series of questions. We weren't just looking for these islands of plastic, but the fact that it was getting small and getting into the food chain, the same food chain that we are at the top of, then it opened up all sorts of new questions about what this might mean for our health as well. So I decided to have my blood tested to find out which of those chemicals that we're finding in the sea and in plastic, what might be inside me. And so working with the United Nations, we chose 35 chemicals that are banned because they're toxic to humans. And of those 35 chemicals, we found 29 of them in my blood. Now, this really changed things for me. I think mostly because often when we're hearing about environmental problems, it's something that we're reading on the news or watching on TV that's happening somewhere else, that's impacting someone else in the future. But this made me realize that actually already we have a chemical footprint, something that we will never get rid of. So this test sparked a whole new series of voyages for me, eXXpedition. A series of all women's voyages sailing around the world looking at plastic and toxic pollution. Because the more I found out about those 29 chemicals I found inside my body, I realized that actually being a woman, those chemicals that are endocrine disruptors that mimic our hormones are really bad news during pregnancy. And we can actually pass them on to our children when we give birth. So I thought, why not tackle this female-centered issue with an amazing team of women? So we put together this project in 2014. It's grown from strength to strength over the years to now eXXpedition round the world. And in October last year, we set off on board sailing vessel Travel Edge from Plymouth in the UK, across the Atlantic, through the Caribbean, the Panama Canal, to where the boat is today, on the edge of the Galapagos Islands. And in about an hour, it's going to be setting sail across the South Pacific towards Easter Island. So the main goals of eXXpedition around the world is really about going out there to do scientific research, to tell stories of really what's happening in these far out of sight, out of mind places, and to build an army of amazing women who understand both what the problem is, but also the role that they can play in solving it. So on this 2-year mission, we have 300 women joining us, just 10 at a time, on this journey around the world. So I want to share with you a little bit of what we've been seeing on these voyages. This was a leg across the North Pacific. We've been sailing through the North Pacific Gyre for 7 days, and we can't believe what we've seen.
Plastic bottles, toothbrushes,
plastic bags,
buckets and barrels,
a lot of rope,
more pieces of rope, nylon rope,
the constant stream of small bits of plastic,
a cigarette lighter,
fishing crates,
microplastics. We saw one huge fishing net tied up together,
seeing these beautiful dolphins and then chunks of plastic next to them.
It's the sheer amount of pieces.
It's literally a plastic soup.
Large plastic lids for containers.
A washing basket.
Half a toilet seat.
We saw a chair
with all 4 legs.
All these items once belonged to someone, and they definitely don't belong in the ocean. So that bigger ball of net that you could see, this is kind of as big, as close as you do get to a kind of island, and it's a bit like an iceberg. It's 10 times bigger under the water than it is on the surface. Far too heavy for us to get on board the boat. So instead here we attached a satellite tracker so that the scientists could monitor both where it was moving, and so a few months later a big boat could go out and clean this up. And when they did, the scientists, the biologists, were then able to look at what was also growing on this plastic, because what we find is that the algae comes along and then the little fish come along to eat the algae, and that attracts the bigger fish and then the even bigger fish, and you have the sharks come along as well, which is why Anna jumped in behind me on Shark Watch. Not sure what she was going to do when she saw one down there, but it's actually quite common that we see entire ecosystems hanging off the bottom of these bits of debris like a coral reef, but then they move thousands of miles across an ocean to a place that they don't belong. So the more we look into this issue, the more we realize there's no end of challenges that it brings. But as I touched on earlier, actually the biggest problem is the smallest pieces. We're in the very middle of the North Pacific Gyre, and when we look out at sea, it looks like a beautiful blue ocean. It's only when we put this trawl through the water with a very fine mesh net do we realise that actually most of what we're looking at right now is covered in these tiny fragments. We deploy the trawl for 30 minutes at a time, and we're taking a tiny slice, just this wide, for a mile, which just makes you wonder really how many are out here in this vast ocean. The samples we're collecting on board are going to be used for a number of things. Some will go back to Hawaii Pacific University to be analysed for the toxic chemicals that are adhering to the surface of the plastic. The rest of the samples are being analysed right here on board Sea Dragon. We're looking at pellet, fragment, film, line and foam. Once we work out what these plastics are, we can better understand where they're coming from and how to stop them getting into the ocean. So we now know that there's over 5 trillion fragments of plastic floating on the surface of our ocean. What we don't know is how many have sunk down to the depths in a place so deep that we can't even measure what's going on down there. And it makes us realize that trying to clean up this issue is just the most enormous challenge. And that right now the biggest opportunity lies at the source, right here at home on our doorstep. And we need to turn off that tap of plastic that's actually getting into the ocean in the first place. Of course, there's so many different ways that we can do that, and one of the things that we talk about at eXXpedition is the idea that there's not one silver bullet solution that's going to solve this problem, but that the great news is there are hundreds of solutions, and we need all of them coming from every sector. We need government to step up with legislation, we need industry to come up with new technologies and new systems, and we need consumer behaviour to change and attitudes towards this problem to shift as well. So some of the science that we're doing on board that we hope that will help lead to some solutions, this is us using the FTIR machine on board Travel Edge, and this allows us to work out the polymer type of the plastic, this very anonymous microplastic that's in the sea. We're trying to understand, well, what is it? Where might it have come from on land? What fungi is growing on it that can help us determine which continent it might have come from? And by trying to understand where it's come from, we can really pinpoint on land where the solutions lie, where in industry things need to change, and where perhaps solutions for working on the very particular types of plastic that we're finding out in the ocean, we can then implement, hopefully, with our partners at TOMRA. So trying to make this plastic less anonymous is absolutely critical. And we're really glad to be working with TOMRA, who plays such an important role on providing one of the really important solutions to solving this problem. And we realise more and more that by standardisation of plastic on land and working with governments on how you can inflate the price of plastic so that it has a value to then be able to stay in the loop, is something that we really need to do to be able to see that plastic that we are using remain on land inside systems. And then beyond that, we're switching to other kind of alternatives that don't use it at all. So please do follow along the journey over the next 2 years that will actually bring us back via Oslo before we come into the UK, which we're very much looking forward to. And I hope to be working with you all more and more in the future.